this is Pete Singer. I'm here at the ConFab with Dalia Vernikovsky, who is the CEO of Applied Seals North America. How are you enjoying the ConFab so far?
I'm doing fine, Pete. I now know actually why people say what happens in Vegas stays in Vegas, but having a bunch of fun.
Okay. Well, that's what the ConFab is all about, having fun and actually some serious meetings, of course, too.
Yeah.
So one of the things we'd like to talk about is O-rings and seals, which I think is probably a misunderstood or underappreciated component in the fab, and there are thousands of them in the fabs. Can you tell us why those are so critical?
Certainly. Well, again, there's a seal in every part of the equipment channel, as you said, and some very critical ones in the process. So I think everyone has been focused all the years on moving down the nodes, going after now even the 10 and the 7 nanometer world and the 450 world. That's great. And I think there's been advances, unique advances in those areas. But then what's forgotten is the hardware. Mm-hmm. And of course, there's a ton of issues around the hardware. So what hasn't happened is people looking at the subcomponents as part of the hardware that introduces contaminants. So I think people are well aware that seals are a contributor, but then what do you do about them?
Okay.
So that's where we're at.
Okay. And so there are some standards for chemicals and gases and things, but not really too many standards for components and subcomponents.
No. There's actually an amazing few. There's a few in UPDI, in ultra pure water. There's none really for pumps. There's none for seals. There's none for actually mass flow controllers of any, and it's really irrational that an industry based on so much copy exactly and so much consistencies in the process would overlook things of that, and it's been done. One of the main reasons is that most of the hardware was actually based on a very strong, mechanically sound material called Viton. It's the workhorse of the industry. When you're doing that, and this O-ring has the thousands of parts per billion of the metallics that make it strong, they overlook the fact that now you're moving to a polymer that's chemically resistant, and it's asked to do the same type of sealing that was utilized by Viton. And there's a huge gap from the awareness of how you use these polymers instead of the Viton it was all developed for.
So what kind of problems would typically crop up in a fab, and are they aware that they're even going on?
So one of the big problems everyone is talking about is manufacturing and actually the inconsistencies. Part of the issue is when you aren't sure if a seal is going to fail or what time it's going to fail, then it's going to lead to all the inconsistencies. There's instability, and everyone wants that today. Predictive maintenance is a big topic everyone talks about. So if you don't get your arms around some of these subcomponents and know and predict or have at least an understanding of the failure modes, let's say, or the times that they could be utilized, then you're introducing or enhancing an issue that hasn't been addressed yet. So that's an important area.
Which could lead to poor yields and variability problems. Absolutely. And all kinds of issues.
Variability, big issue in the fabs, and that has to be overcome if you're going to reach that level of success. Okay,
so my understanding is that it's not so much during the deposition or the etch processes that can cause wear and tear. It's more the actual cleaning, the NF3 or oxygen
I'm
chemistries.
Always laughing when the world introduced NF3 into the cleaning gas. It made a lot of seal people very, very happy. It's NF3 will destroy the bases of most materials out there. So yes, you need a very chemically resistant seal, but then the problems are that the education of how these polymers are to be used is lacking. You have to design out the problems of these seals. They're very weak in their strength components because there are none. There's no, if you will, most of the carbons are things that make seals very, very strong. You take that out, and you're left with a very, very chemically resistant material that now needs to be designed around those properties. And the problem is that you're measuring today the same properties that you did with Viton, which was developed many hundreds of years ago, onto these polymers. So there's no consistent way of measuring, A, and there's no standardization around how you actually influence making them a better seal, actually. So this is one of the major issues that we're addressing.
Okay.
So to your knowledge, we have started not just the standards process, but a subcomponent committee. It's called Semi-Components, Instruments, and Subsystems, that I'm happy to include both the end user, the OEM, the subcomponents themselves, and Semitech in actually the real-world collaboration and trying to move some form of guides from the beginning, the initiation of the subcomponents, all the way to the end user and a measurement that actually we can all look at and say, okay, we have identified the seals and maybe some of the attributes and the deficits of these parts, and the same with the pumps, and the same with all the other subcomponents. So,
And that's the SCIS working group. Okay,
industry
excellent.
loves acronyms, right?
Yes,
So-
that's the TLAs. And also there's a defectivity standardization committee within SEMI?
Yes, so that's all part of it. So it started as the subcomponent group, and then it's broken up into my favorite, which I'm heading, the defectivity team. And there's also a BKM team, which will eventually drive into the same group. But there's some great advances, because I think now that there's at least an awareness of some of the issues and a realization that it has to be addressed if they're going to get to that sub-component level, that nano level, they have to address some of the issues. Hardware was developed many, many, many years ago. There isn't that much difference in the hardware today.
Okay. And how would you suggest people get involved with the standards committees? Just show up and go online and...
It's open to everybody. Anybody and everyone can contribute and should, as these guidelines are in place. And I'm happy to be able to enable that on our site, on your site,
Okay.
and see them next year in ConFab, right?
That's right. Okay. So check our sites. All right. Thank you very much.